Okay. All right, there's everybody. All right, so this is our recording for Chemical Eric, third hour. So everyone has made their slides. Breakout group one had to talk a little bit about growth hormone, and it's going to be a hormone that is secreted from the anterior pituitary gland, and it stimulates, just like they said, the multiplication and the division of chondrocytes, which are the cells that make up cartilage. But it's also going to cleave or break down fats and proteins in order to build cells, largely in the muscle and, like I said, in the cartilage. The other thing that growth hormone does is it stimulates the liver to release another chemical called IGF-1, which stands for insulin-like growth factor 1. And that's going to be really important in just a second. The thing about growth hormone is that it's released in pulses from the anterior pituitary, like it's not released in a constant steady stream. And so you can't just like draw somebody's blood and directly measure growth hormone levels, because depending on the person and depending on the time of day and yada, 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 those levels can vary. And they especially vary from one person to the next. Like it's not the same as like melatonin. Like for most people in the general population, melatonin is going to increase or spike in concentration in the blood at nighttime, and then it lowers during the day. But there's nothing predictive about growth hormone from one person to the next. Instead, if there's if a physician is suspicious of a growth hormone problem, what they'll usually do first is they'll measure the levels of IGF-1. So now breakout group 2 had to start reading about IGF-1. IGF-1, as I said, is stimulated for release by the liver by growth hormone. And then IGF-1 has some broader effects around the body than GH does. Like GH, it does, but it's not going to be as powerful an effect as IGF-1. So IGF-1 is kind of like the little minion of growth hormone. Basically IGF-1 is going to cause cellular division and growth of tissues. So like I said, IGF-1 is going to have a more constant level in the body. So if there's a suspicion that growth hormone is off, they'll first draw IGF-1. If IGF-1 levels are low, then that usually means that growth hormone levels are low. If IGF-1 levels are high, that usually means that growth hormone levels are also high. So what the physician will do is they'll order either a growth suppression test to see if the person makes too much growth hormone, or he or she will order a growth hormone stimulation test if they suspect that the patient is making too little growth hormone. They'll kind of do the growth hormone test after IGF-1, because if IGF-1 is normal, then there's no reason to put the patient at risk with a growth hormone test. And just to kind of put them through all of that anyway, because like they have to either drink a glucose drink or they have to give them insulin. And whenever you give somebody more insulin, you could be putting them at risk for insulin shock. So, there's a lot of other things that are associated with that. Does anybody have any questions if you're still here so far? Okay, so just remember, if you guys have to go, because it's 11 o'clock right now, then you can go, you know what your assignment is, but of course, feel free to stay on. Okay, so breakout group 3 had to read about a couple of different things. And first of all was the pituitary gland. And I have to say that in talking with group 3, they had some really good insights about these hormones. So what they said is that the pituitary gland is going to produce a lot of different hormones like growth hormone. They've also put a couple more on the slides. And they stated that FSH and LH are probably two of the most important ones, because in the male body, they are going, especially LH, is going to help to stimulate the synthesis and the secretion of testosterone. And it said in the story that Eric was suffering from low testosterone. And low T in the male body means that you're going to have low sperm count. You might have a low sex drive. And remember how they were talking about how he didn't really have an interest in the opposite sex. That could be attributed to low testosterone. But also, when we get to the testosterone slide, this could also affect bone health. So we'll get there in just a second. So really good insight on the part of group 3 on these hormones. Let's see, breakout group 3. Oh, wait, I also wanted to just mention, they also mentioned adrenocorticotropic hormone. This is a hormone that stimulates the adrenal gland, which is a small gland that sits on top of each kidney to release a hormone called cortisol, which is then changed into cortisone. Um, the cortisone suppresses the inflammation process. It suppresses the immune system. And so that could be a reason why those sores on Eric's lower leg may not have been healing properly. But again, we've got another slide that we'll go through. So I'll wait to talk more about that when we get there. All right, breakout group 3 also had to talk about gigantism and acromegaly. And you guys had to read a little bit about this from your textbook. But basically, the difference is this: gigantism is going to occur earlier in life because you still have to have the epiphyseal plate present in the bones. Now, the epiphyseal plate is where chondrocytes start to multiply, and they're going to cause the bones to grow longer. And if you get a spurt of growth hormone during this time when the epiphyseal plate is still present, then the person is going to get some really long bones, and they're going to be giant-like, but their bones are proportional to each other. Once that epiphyseal plate ossifies and turns into the epiphyseal line, those bones can't grow longer. But if the patient experiences a spurt of growth hormone, those bones can grow thicker. So that's the difference between gigantism and acromegaly. Andre the Giant, if you know who he was, he had acromegaly. And if you just look at pictures of his face, like you would see, like he's got a really thick jaw, really thick brow bone, sorry. And that's due to this growth hormone that was introduced into his system after those epiphyseal plates had ossified. Okay, and finally, here we are with breakout group 3 and testosterone. It mentions a lot of the things that I already said already to regulate sex drive, bone mass, fat distribution, muscle mass, and strength. I mean, he also had Eric, also, he was tired all the time. He was long and lanky. He didn't have a great deal of muscle mass, and this could be attributed to low testosterone. Go ahead and make sure that you read that stimulated little sentence that they have there, because LH is going to promote the synthesis of testosterone. And so maybe this is a problem with the pituitary gland. You're going to have to wait and look at Chemical Eric Part 3 to see what his test results actually were. Testosterone is going to stimulate osteoblast action. These are the cells that actually build the bone. And then low testosterone can be a factor in promoting rheumatoid arthritis. And so maybe perhaps that had something to do with the fluid that was collecting in his knee. The only thing I can say about that is that they couldn't find anything else wrong with his knee. Like, they didn't find any antibodies in his knee to suggest rheumatoid arthritis. So I'm not exactly sure that was the direction that Eric's clinicians were going in with that, but that's a really interesting point of fact. All right, group 4 was talking about magnetic resonance imaging, and it's going to be different from X-rays. You know, X-rays do a really great job of visualizing bone, not always so much of soft tissue. So this is going to allow clinicians to take a look at that soft tissue to see, like, if there's an aneurysm, if there's a tumor, stuff like that. So that's the importance of MRI. Thank you for this is a very good slide on MRI. You guys did a great job. The thyroid gland is a butterfly-shaped gland located in the neck. I know I showed you a picture of that on one of the other presentations that we've done. It produces a bunch of different hormones, um, uh, especially T3 and T4. The TSH is actually coming from the anterior pituitary gland, and then that stimulates the thyroid gland to secrete T3 and T4, and also the precursors of those hormones as well. Let's see. You're talking about hypothyroidism and hyperthyroidism. Hypothyroidism is accompanied by uh, a lot of different signs like decreased metabolism. You could have a goiter, depression, anxiety. All of those things can accompany low secretion of thyroid hormones. And then hyperthyroidism is simply the overactivity of the thyroid. So you have a lot more of those hormones and their precursors found in their blood. Now, usually when they're measuring T3 and T4 and their precursors, they're talking about them as being bound and free in the blood. And so remember that bound hormones are the ones that are attached to transport proteins in the blood, while the free ones are the ones that are not. And it's the free ones that are able to leave the blood and bind to their target glands. So when you look at the test results in part 3, that's what the free means in front of those abbreviations. All right, and then finally, cortisone is going to be released by the adrenal gland. Again, those glands that sit on top of the kidneys, when they are stimulated to do so by the anterior pituitary gland. And as this group has said here, the anterior pituitary releases ACTH, and that's going to stimulate the adrenal cortex to release cortisol, which is converted to cortisone by an enzyme in the tissues and in the blood. Cortisone is something that's called a glucocorticoid hormone. It is stimulated for release in response to stress. So, when you are in a stressful situation, you know, for some of us, that could be right now while we're all quarantined in our own homes. But in order to allow your body to respond to that stress, it needs glucose. And so cortisone is going to stimulate the release of glucose from glycogen in the liver. Cortisone is also going to suppress the immune system. So oftentimes, you know, when you're undergoing a period of a large amount of stress, that's a time when you could get sick. So once again, take care of yourselves, everybody, because if you've got a lot of cortisone flowing through your system during this stressful time, you could be more susceptible, you know, and I'm not talking only about COVID-19, but there are other illnesses out there too, like the common cold and the flu, and that could even depress your immune system even more and make you more susceptible to more serious illness. And so Eric had low cortisone levels, and so this could be causing the swelling in his knee. This could be causing the inability to heal his wounds on his legs, because healing requires the inflammation process. So anyway, you guys did an amazing job on these slides. Thank you very much for your attention and for your time in class today. I'm going to go ahead and stop this video now, and then I'll go back to our conference in case anybody is still there.